All right, moving on to example 2. We're going to factor to find a dimension. And it's a word problem. Woohoo! All right, Sasha has a tech store and needs cylindrical containers to package her voice-activated speakers. A packaging company makes 2 different cylindrical containers. Both are 3 inches high. The volume information is given for each type of container. Determine the radius of each cylinder. How much greater is the radius of one container than the other? All right, so we need some background information in order to answer this question. These containers need to be cylindrical containers, and we're talking volume. So the volume of a cylinder is a formula we need to work with. So volume of a cylinder, V equals pi r squared h, where r is the radius of the circular base and h is the height of the cylinder. Okay, so just to organize our work a little bit, I'm going to call this first speaker, speaker A, and the second speaker, speaker B. So they want us to find the radius of each cylinder and then compare them. How much greater is one versus the other? So we're going to start with cylinder A. Now we know that the volume formula is pi r squared times h, and we know that the height of both containers are 3 inches high. So we know that our height is 3 inches. So what we're going to do is we're going to plug in a 3 for the height of our volume formula. Pi radius squared times 3. So this is our volume formula for a cylinder. We know the height is 3, and we're also given the volume of our speaker over here. So we're going to set this equal to the volume of our speaker. Pi times 3x squared plus 30x plus 75. We have an equation to work with. Our goal is going to be to solve for our radius over here. So how do we do that, right? It looks kind of complicated. First thing I notice is both sides of our equal sign have a pi. Pi is being multiplied by r squared times 3, and pi is being multiplied by that trinomial. So you know what we can do? We can get rid of pi. If we divide by pi on both sides of our equation, this pi cancels out that pi because pi divided by pi is 1, and over here, same thing, pi divided by pi. All right, the left side of our equation is 3 times r squared equals, we have a 3x squared plus 30x plus 75. All right, now this is a trinomial. Why don't we work with this a little bit? I notice that all 3 terms have a common factor of 3. 3 fits into 3, 30, and 75. So we're going to factor a 3 out of that trinomial. That's going to leave us with x squared plus 10x plus 25. And I'm just going to carry down the 3r squared. So kind of like what we just did where we divided both sides by pi, now my r squared is being multiplied by 3, and this trinomial is being multiplied by 3. So why don't we get rid of that 3 by dividing both sides by 3? All right, well this is getting closer to what we want. We have r squared equals x squared plus 10x plus 25. All right, because the left side is the square of something, whatever our radius is, can we rewrite this as the square of something? So, quick check, x squared is a perfect square, 25 is a perfect square because 5 times 5 is 25. Is 10x twice the product of x and 5? And it is. This is a perfect square trinomial. So we can factor this, and here's that check we were doing in the last video. Do we square anything to get x squared? Do we square anything to get 25? Is the middle term 2 times the x times the 5? Because all of that is true, that means that we can write this in factored form as the square of a binomial. So x plus 5 squared. I'm going to carry down the radius squared. So essentially what we have is we are squaring the radius, and it's equal to squaring the x plus 5. So that must mean that our radius is equal to x plus 5. Now we don't know what x is, but whatever x is, we know it's going to be 5 units longer. So there's the radius of our cylinder A, or I guess that is speaker A. All right, so now we're going to follow that same idea mathematically for speaker B. So let's go back up here. Speaker B has the same height as speaker A, so the height is equal to 3. The volume formula for a cylinder is pi r squared times the height. So pi r squared times our height of 3. We're going to set that equal to the volume of speaker B. Oh, look at that one. It's a little bit less complicated. So speaker B has a volume of 3 pi x squared. Okay, so I notice in our volume formula, there's a pi being multiplied by r squared and a 3 being multiplied by r squared. Over in here, the volume of speaker B, we have a 3 times a pi times an x squared. So we can divide by a 3 and a pi all at the same time on both sides, and you'll see why we're going to do this. The 3 cancels the 3, the pi cancels the pi, and we get to carry down just an r squared. On the right side, the 3 pi cancels the 3 pi, leaving us with just an x squared. So what we have now is we are squaring our radius, and that's equal to squaring the x value. So that means that our radius must be equal to x. So find the radius of each cylinder. So speaker A, that cylinder has a radius of, what do we say, x plus 5. And speaker B has a radius of x. So we found the radius of each speaker or each cylinder. And the question is, now the question is, how much greater is the radius of one container than the other? Well, if speaker B has a radius of x and speaker A has a radius of x plus 5, we can conclude that speaker A has a radius 5 units longer, because of that plus 5 longer than speaker B.